Open your book to page 952, and let's start with number 1. It asks you to use a table of values to estimate the value of the limit. So you're looking for the limit of x minus 2 over x squared minus 3x plus 2 as x approaches to 2. To make a table, so you got x and f of x. F of x means y. Now it does not tell you what value to use, so you can choose. So what I'm going to do is, okay, so the approach to 2, so that means your middle is the 2, so you need to get value on either side. So I'm going to use 2.0001 and 1.9999. So I'm going to just use two numbers. Again, if you choose the number carefully, you don't need that many numbers. So use a calculator to enter the numbers. So 1.999, when you enter, you get 1.0001001. Over here, you get 0.99990001. So you can see that both value approaches to 1. Okay. Again, this getting close to 1, this getting closer to 1. Again, if you're not sure, another way to do this is by average the two numbers. Okay. Again, when the two numbers are fairly close, to get more exact, you can just average the two. But just look at this, you can see it's 1. Okay. So again, both are approaching to 1. Yeah, let's go to number 3. The limit of 2 to the x minus 1 over x as x approaches to 0. So to make the table, so that your x, f of x means y. So again, you want to approach to 0, so the middle is the 0. So notice, again, you got to watch this so you know what you're doing. Whatever number you're approaching to, that is the middle. So you approach to 0, so here's your 0. So you have to get number on either side. So make sure you have this number over here to help you to visualize how to get the number on either side. So I'm going to use 0.0001. And this one I'm going to get negative 0.0001. So again, if you substitute the numbers in here and you work it out, you get 0.6931712. This one over here, you get 0.69312316. So by looking at that, you can see that this approaches, at least you can see that the first 4 digits. So this will be 0.6931. Okay. So again, if you know what you're doing, you don't need to have a lot of numbers. Like this one, 2 numbers should able to give you a clear picture of what the limit is. Okay, number 5, you're looking for the limit of natural log of square root of x minus 1 as x approaches to 1 from the positive side. So you got to pay attention to these. So again, you got x and f of x. Now this one, you're approaching the 1 from the positive side. So you can think about your number line. So here is your 1, right? And you're coming from this side. So you want to get closer and closer. So what I'm going to do is I'm going to get the 3 values instead to get more clear. So you got 1.00001, 1.0001, 1.001. Okay, so you can get closer and closer. Again, you want to approach 1 from the positive side. Okay. So again, if you enter the number in here, you're going to get negative 3.45387. You enter this one, you use your calculator, you get negative 4.60517. Enter this one in here, you work it out, you get negative 5.75646. So you can see the number does not approach a certain number. It's getting more and more negative. So in this case, it does not exist. It does not approach a fixed number. Okay, let's go to next one. Let's go to number 7. So number 7, you have the graph over here. So they give you the graph. So if you look over here, you have this graph over here. and you have to use a graph to evaluate the limits. So so for part A, you're looking for the limit of f of x as x approach to 2 from the positive side. So you're coming from the positive side and you want to get to the 2. Okay? So over here is the 2. Notice it goes all the way up. So it goes to infinity. So in this case, it does not exist because it goes to infinity. Again, if you look at this over here, see the 2, it goes all the way up. So the limit does not exist for part A. Okay, for part B, you're looking for the limit of f of x, and you want to x approaches from negative 3 from the positive side. So here's your negative 3, and you want to approach from the positive side. So it gets to approach to 2.4. Okay. And let's go to C. You're looking for the limit of f of x, and you're looking for negative 3 from the negative side. So again, here's your x equal to negative 3, and you come from the negative side. So again, your approach is to equal to 2.4. Okay. Let's go to D. You're looking for limit of f of x as x approaches to negative 3. Okay, so this is from both directions. So again, if you notice, if you go from this direction and from this direction, both approaches the 2.4. Okay, let's go to E. You're looking for limit of f of x as x approaches to 4. So here's 1, 2, 3, 4. So from here, you approach from both directions. So you're going to be 0.5. Right, just look at the graph. So go to F. You're looking for limit of f of x as x approach to infinity. So if you look up here, infinity, notice this one keep going. When it approaches infinity means you're looking for horizontal asymptote on this side. So you can see the horizontal asymptote is going to be 1. So this is equal to 1. Again, you notice the limit by y equal to 1, right? Okay, let's go to G. You're looking for limit of f of x as x approach to negative infinity. So negative infinity over here, so it's going to keep going to the negative side. So you can see that it's going to oscillate and it's getting closer and closer to y equal to 2. So answer would be 2. Let's go to H. You're looking for the limit of f of x as x approach to 0. So here's x equal to 0. So when you approach from this side, y equal to 0. When you approach this side, y equal to 0. So this one equal to 0. Okay. Next, let's go to number 9. Let's go to page 953. And let's do number 9. The limit of x plus 1, x minus 3 as x approach to 2. So this is equal to, again, first you want to do is see if you can substitute directly. So if you can substitute directly, go and try that. So this is equal to 3 over negative 1, so they equal to negative 3. Let's go to 11. You're looking for the limit of x squared plus x minus 12 over x minus 3 as x approach to 3. So this one you cannot substitute directly. So what you want to do is you can either use a division to divide, or you can go and do the factoring to cancel. So you're going to get x plus 4 x minus 3. You can use your master product, right? 1, negative 12, right? So you're going to get 4 comma negative 3. So that's how I get that from, right? And so this cancels out. Now you can go and substitute. Now make sure you keep your limit until you substitute. As soon as you substitute, you can drop the limit. So this becomes 3 plus 4, so equal to 7. So make sure you follow through with your limit until you substitute. As soon as you substitute, then you can drop the limit. Let's go 13. Yeah, the limit of u plus 1 square minus 1 over u as you approach to 0. So you can use this one, try the direct substitution, cannot, so you have to work it out. So go and multiply out, you get u squared plus 2u plus 1 minus 1 over u. So this and this can cancel out, and this one you can factor the u. So from here you factor the u, you get u times u plus 2 over u. So now this can cancel out. So once you cancel out, then you can substitute directly. So you substitute directly, you get equal to 0 plus 2 equal to 2. Okay? Okay, let's go to number 15. Number 15, the limit of x minus 3 over absolute value of x minus 3. And you want to have x approaches to 3 from the negative side. Now the way to get rid of the absolute value is if the inside, if the absolute value of positive okay, if you have absolute value of positive, right, then this will stay the same. So whatever you have over here, then you will equal to that number. Okay? Then if it's negative, if the inside is negative, then you have to make into negative of that. Okay? So that's how you get rid of the absolute value. So if you notice that this is x come from the 3 from the negative side, that means from here, if you come from the negative side, from the number line, that means x is less than 3. Now, if x is less than 3, therefore this is negative. That means this has to take the opposite of that. So this is equal to the limit of x approaching 3, negative. So this is going to become x minus 3, and you have to take the negative of that. Because x is less than 3. Okay? Because when you come from the negative side, x is less than 3. So when x is less than 3, so this will become negative. So to get rid of the absolute value, you have to take the negative of that. And so this is equal to, so this cancels out. And now when you substitute, there's nothing to substitute. Oh. Back up. Right, this cancels out, right? So you got negative 1. And since there's nothing to cancel, there's nothing to substitute, the answer will be just equal to negative 1. Okay, let's go to 17. You have the limit of 2x over x minus 4 as x approach to infinity. So again, when x approaches infinity, you're looking for a horizontal asymptote. So horizontal asymptote, you just look at the highest degree term, and this one it will cancel out, it will just equal to 2. Let's go to number 19. You're looking for the limit of cosine squared x as x approach to infinity. So if you notice the cosine graph looks like this, right? It goes up and down, right? Now cosine square, it will square each part, so it will look like this. So the positive, you just going to keep the same thing. The negative, when you square, it becomes positive, so it becomes like this. But again, the value go up and down, it does not approach to a certain fixed value. So this one, the limit does not exist because it go up and down, it does not get a fixed value.